Welcome to Notes 2.56. I am super excited today because this is the section of geometry where we begin proofs, which are totally awesome. And I'm sure you heard all sorts of fabulous things about them. So here we go. We are going to begin, though, by talking about the properties of equality and real numbers. And you should already be familiar with these from Algebra 1. But just to quickly remind you, we have an addition property, which says if I add the same thing to both sides of an equality, then it stays balanced. We have a subtraction property, which says that if I subtract the same thing from both sides of an equation, then it stays balanced. We have a multiplication property, which guess what, says if I multiply both sides of an equality by the same thing, then it's still equal. And we have a division property that says that if we divide both sides of an equality by the same thing, then it's still equal. There's a little caveat to that. C cannot equal 0 because we all know that nobody can divide by 0 except for Chuck Norris. All right, and then finally we have our substitution property, which says that if A equals B, then I can substitute B in for any place that A is in any expression, and also our distributive property, which says that I can go ahead, if I have something outside parentheses, I can go ahead and distribute to what's going on inside the parentheses. And these are properties of equality, and I can only use these when I see equal signs. And you might think that's a weird thing to say, but trust me, later on when we start to do proofs, that's going to become really important. The other properties we're going to talk about are properties of congruence, but these also apply to equalities. Okay, so I can use these properties when I have equal signs going on or when I have congruent signs going on, unlike the previous page, which I can only use with equalities. And there's a little note here that says that these properties apply to both segments and angles, and you need to specify which one you are referring to when you use these properties in proofs. So my three properties of congruence are reflexive, symmetric, and transitive. And my reflexive property simply states that segment AB is congruent to segment AB, or angle A is congruent to angle A. And you're like, of course it is, Mrs. Uken, you crazy person. And there will be a point to this. It'll be more important in upcoming units than it is in this unit, but it's critical that you remember that this property exists. All right, my symmetric property basically states if AB is congruent to CD, then CD is congruent to AB. Or if angle A is congruent to B, then angle B is congruent to angle A. So I just basically flip the order around like looking in a mirror. And then my transitive property, I like to call my if and then property, which states that if AB is congruent to CD and CD is congruent to EF, then the first is congruent to the last. And it works also with angles. And so what I meant by this note up here is if I'm going to use one of these properties as a justification, let's say this angle one right here, the reflexive property, I would call it the reflexive, and this is shorthand because we're not going to make you write this all out in a proof, so the reflexive property of angle congruence. All right, that's how I would refer to it in my proof. I specified which property I'm talking about, the fact that I'm talking about an angle, and the fact that I'm talking about congruence. So I mentioned that this is the section where we begin talking about proofs, and here we go. A proof is simply a logical argument that shows that a statement is true. And remember that we had these things in our first unit, we call them theorems, that were not like postulates in that you had to prove them to be true, and the way you prove them is with a proof. And so the first theorem that we talked about in the textbook was called the congruence of segments theorem. And it states that segment congruence is our old friends, well maybe not so old, our friends from the previous page, reflexive, symmetric, and transitive. All right, we need to name the properties illustrated in this statement. What is this first property right here? I'm pausing so you can say it out loud at home like a crazy person. All right, this is my if and then property, which means that it is my transitive property. And since we're talking about angles and we're talking about congruence, it is my transitive property of angle congruence. And then in B, which property is this? All right, well, this is clearly my symmetric property. And this time I'm talking about segments, and I'm still talking about congruence. So this is the symmetric property of segment congruence. We are going to begin proofs. Now, I know that you guys have probably heard a lot about proofs from your classmates who've gone before you, and you're probably a little freaked out by them, but honestly, they're not so bad. A proof is nothing more than a step-by-step roadmap for how to get from one point to another. And just like a map gives me a way to get from one place to another, if I wanted to go from, for example, our classroom to the front office, I could walk out the door, all the way down the main hall, down the front stairs, boom, I'm at the front office. That would be the most efficient way. But I could also go down the back stairs, go outside in front of the building, walk around the front of the building, come in through the front entryway, and I would still get to the front office. I could even, if I were a crazy person, go out my classroom, go down the back staircase, go out to the back of the school, walk all the way around the school, past all the gyms, past around the auditorium, come around the front of the school, and I would still get to the main office. It would just take me a lot longer, and I would have had to go through a lot more steps. Well, same thing holds true with proofs. There's usually an efficient way to do a proof, and then there's proofs that have many more steps, but that still get you to your endpoint. Our goal is to be efficient, but as long as we get there, we've at least accomplished our mission. So let's talk about proofs themselves. Typically in a proof, we tend to do two-column proofs. One column will be the statement column, and the other column will be the reasons column. So this says what I did, and this says why I did it. We're typically given some information. So in this case, I'm given this. It happens to be an equation. Most of the time it won't be, but in this case, we're going to begin by doing algebraic proofs. So I'm given some information, and I have to prove some information. So this right here, the part that comes after the prove, this should be my last step in my proof. And you can see that it is. And usually, but not always, the given is the first step in my proof, which you can see here. And the nice thing about that is when the given is my first step, then my reason for it is because that's what I was given. So I just write given. Now, I have to decide, how did I get from this step to this step? Well, clearly, I multiplied both sides by 2. And when I multiply both sides of an equation by the same number, that is my multiplication property of equality. Now, to get from this step to this step, I clearly distributed. I multiplied 2 times negative 2x, and I got negative 4x, and so on. So that would be my distributive property of equality. And then to go from this step to this step, it looks like I subtracted 3 from both sides. And whenever you subtract the same thing from both sides of an equation, that is your subtraction property of equality. And then, obviously, I divided both sides by negative 4, which means that my final step, the reason for it, was the division property of equality. And that is a proof. I went step by step by step, laying it all out, not skipping anything, not combining any steps, and I gave a reason for every step that I took. Now we are beginning with algebraic proofs because you already know how to solve algebra problems and you are familiar with the properties, so it's an easy way to ease you into the world of proofs. They will get a little more complicated, I'm not going to lie to you, but you can do it. Speaking of being able to do it, why don't you go ahead and do this one on your own? Here's your given information, and here's what you need to prove. I'll tell you what, I'll go ahead and get you started. All right, that's our first step, given. Now you hit pause, you write down the remaining steps, and then come back and see if you were right. Okay, so our next step was the multiplication property of equality because we multiplied both sides by 3. Then we distributed that 3, so we got the distributive property of equality. Then we subtracted 15 from both sides. So that's our subtraction property. And then finally, we divided both sides by -2, so that is our division property of equality. Did you get it right? Great. All right, this one's super short, super easy. You do it. Hit pause. And this is what you should have gotten. Now this last step could either be the multiplication or the division property, whether you thought about it as multiplying both sides by -1 or dividing both sides by -1. Totally your call. All right, one more time. I want you to do this one on your own, so hit pause right now, write it, and then come back and check your answers. Here's what you should have gotten. All right, so sometimes we're going to give you the whole left-hand side, and you're going to have to do the right-hand side. Sometimes we're going to give you bits and pieces. And this one is like being a detective. You have to think about, okay, what information do I have? What hint, what clue do I have? How does that help me solve the mystery of what goes here in the block? And then eventually, all we're going to give you is the given and the prove, and you're on your own. But that's a ways off yet, so don't worry about that. All right, so here's what I'm given. Obviously, my reason for that is given. My next step, because I'm multiplying both sides by the same thing, is the multiplication property of equality. And then I need to write down what comes next. Well, I'm told that it's the distributive property, so obviously I just need to distribute 2 to my equation. And I wind up with 8 minus x equals 7 minus 2x. All right, and then something happened between here and here. And what happened was I subtracted 7 from both sides of the equation. And then I'm told to add. Well, if I'm going to add, I should probably add that -x, which means that what I get here is 1 equals -x. All right. So now I get -1 equals x, which means I either multiplied or divided both sides by -1, so you can pick one of those. And then I get this thing here. Well, these two mean the same thing. And the reason why I needed to flip this guy around is because it told me to prove that x equals -1. So my final step needs to look exactly like what I was given to prove. And what's the thing that allows me to basically mirror image my step? It's one of those properties. Did you guess the symmetric property? And notice this time we were talking about an equality, so I wrote the symmetric property of equality. All right, those 3 properties, symmetric, transitive, and reflexive, are very important in proofs. Now, geometry proofs work exactly the same as algebra proofs. We've still got 2 columns going on, right? I still have my statement, and I still have my reason. I'm given some information, and I need to prove some information. And frequently, I'm also given a diagram. And if that diagram is marked in any way, then that constitutes a given. Okay, but this diagram simply is for us to reference. And the piece of information that I'm given is that ray BD bisects ABC, all right, angle ABC. So BD bisects ABC, that is my given. So I can write given down. Now, frequently when I see a statement like this, my very next step is going to be to write down definition of angle bisector. And that will be the reason. And the definition of an angle bisector is that it divides an angle into 2 congruent parts. So, oh, it's not there. So sad. What that means for this is if my angle is bisected, it means this. It means that angle 1 is congruent to angle 2. That is the definition of an angle bisector. And then this next step, definition of congruent angles. Well, what's the definition of congruent angles? It's that they have the same measure, right? Congruent angles have the same measure. So what it must want me to do is talk about the measures of these angles. Well, if angle 1 is congruent to angle 2, then the measure of angle 1 equals the measure of angle 2. And this is an important step, and we're going to do this a lot in proofs, because what I'm getting ready to do is I'm getting ready to do some kind of funky addition or something, and I can't do any of those properties, addition, subtraction, multiplication, division, distributive, or substitution. I can't do any of those with congruency. I need to change it into an equality, and then I can do that. And so that's what we've done here. We've taken our angles and we've turned them from a congruency into an equality. And these two are now equal. And now I'm talking about their measures. So I've got the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Well, what do we know allows us to say that the measure of angle 1 plus the measure of angle 2 equals the measure of the big angle? When I add these two angles together, they equal the big angle. So I think you can see where I'm going here, and where I'm going is my angle addition postulate. When I have two smaller angles and I add them together, they equal the big angle. That is my angle addition postulate. And in geometry proofs, you are going to spend a lot of time bringing in definitions and postulates and theorems into the proof. All right, so I've got this and I've got this, and they look very similar, but they wouldn't want me to write the same thing down twice in a row, so there must be something else going on here. And this is my clue. I'm going to use the substitution property of equality. Well, the substitution property says if two things are equal, I can substitute in one for the other in my equation. And right up here, I've been told that the measure of angle 1 equals the measure of angle 2. So I must be able to substitute in my equation for angle 2, angle 1. All right, and then I have this thing that calls it the distributive property. All right, this is a little weird, so just follow me here. Basically, instead of distributing, I'm sort of undistributing. I'm combining my like terms. And what I'm doing is, remember that I've got a roadmap. I know where I'm headed. So this is where I'm headed. And I know that if I add my angle 1's together, then I have two of them. So I have 2 times the measure of angle 1 equals the measure of angle ABC. All right, and that is technically classified as the distributive property. Okay, here's my problem with this. Sometimes your book is a little lax in its proof. And this is a proof we copied directly from the book. And it ends here. But this and this do not look the same. We need to turn this into this. So my final line has to be exactly what I'm given to prove. And what I'm given to prove is not 2 times the measure of angle 1 equals the measure of angle ABC. It's the measure of angle ABC equals 2 times the measure of angle 1. So I actually have a step 7 here. And what did we just do? Well, we flipped these two around. We said if 2 times the measure of angle 1 equals the measure of angle ABC, then the measure of angle ABC equals 2 times the measure of angle 1. And that is my symmetric property. And this is a property of equality this time because I've got an equal sign going on here. So, not happy with your book? They left out a critical step. And that's going to happen from time to time, and I expect you to go ahead and add that step in. All right, we have another proof going on here, and it says that we are given that AB equals CD. And that's what our diagram shows, AB equals CD. Well, our diagram shows they're congruent, but we're given this. And we need to prove that AC equals BD. And they've given us all of the statements, and all you have to do is fill in the reasons. Well, I've given you all the possible reasons down here, and I want you to go ahead and pick out which ones go where in this, and then come back and check and see if you got it right. So hit pause right now. Write them all down, and then hit play again when you're ready to see the answer. All right, so this is what you should have gotten. We begin with our given, and then we have a statement that says that AC, the big segment, equals the 2 smaller segments added together. That is my segment addition postulate. Same thing here, BD, my big segment, equals my other 2 segments added together. And for some reason, students don't like writing the same thing next to each other, or one right after the other, but it's okay. This is clearly segment addition postulate. This is clearly segment addition postulate, so it's okay to write it twice. Now, down here, we have AB plus BC equals CD plus BC, and they helpfully highlighted it. All right, basically, all that happened is I went from this statement right here and I added the same thing to both sides of it. Okay, so I ignored these previous two statements and went all the way back to the first statement. And that is simply my addition property of equality. Now, here's where it gets fun. The reason why I did that is because I wanted AB plus BC. Here's AB plus BC, and it's equal to AC. So I took that AB plus BC and I replaced it with AC. And then over here, I had CD plus BC. Well, here I have CD plus BC, and it's in a different order, but that's okay because addition is commutative, and that's equal to BD. So I took that CD plus BC and I replaced it with BD, and that's how I wound up with that last one, and that is my substitution property of equality. Super handy, and you're going to see that a lot. If you have any questions about anything we covered in today's notes, please talk to me in class. Thanks.